All right, so in part E, it wants to determine the distance between the landing points of the two blocks. All right, so we see that we have got this block right here, and this block, like we said, is zooming along with a constant velocity v. So this is a constant velocity, and this is the velocity that's going to be going off the edge. So this is pretty much the path of that block. And so we see that this is some change in x here, and that's what we're looking for. We're looking for that change in x. And so we're going to say change in x equals v naught t plus 1/2 at squared. We know that we have no acceleration in the x direction, so your change in x just ends up equaling this v naught t. So what is this v naught? What is this v naught, this constant velocity that this block goes? All right, how did it get to this velocity? Well, before it was constant, it was accelerating. So remember that back here, for this distance h, all right, because remember that was the distance that this block had to fall. For this distance h, our acceleration was g all over 2. Okay, so it started right here from rest. That's where it started from. And then when it got to right here, that's when we got to this new velocity right here. So that's when we got to this new velocity, is from this acceleration from rest. So what is this new velocity? Because we can't express this in terms of v naught. We just can't use just v naught here because they told us that we can only use h, m, and g. So we're going to have to figure out what is that v naught. And so looking at this, we see that our acceleration is g all over 2. Our v naught in the very, very beginning, our v naught is 0 meters per second. We're looking for this v, all right, because that's the velocity that this thing is flying off the edge with. And we see that our change in x is this h. And so you could do this in multiple ways. You can remember that your time was such and such, and you could, I mean, there's multiple ways that you could do this. So we end up, we can just use this equation. So v squared equals v naught squared plus 2a change in x. Cross out that because that's 0, so it doesn't really matter anymore. And square root both sides. So v equals the square root of 2a change in x. And so this ends up being v equals square root of 2 times g all over 2 times h. So these 2's cancel out and end up with this v equaling this square root of gh. And again, you can do this in multiple ways. All right, so we have just found that part of the equation, so square root of gh. Now we need to figure out, so what is the time that it takes for this block to get right here? So what is the time that it takes? And we know that whenever we see a problem like this, we're always going to look in the y direction to figure out time. All right, so now what is time equal? So you're going to say, we look in the y direction, so change in y equals v naught t plus 1/2 at squared. And we know that because this is going off horizontally, we don't have any initial velocity in the y direction. So your change in y ends up equaling this 1/2 at squared. And you're looking for the t, so multiply both sides by 2, and then divide both sides by a. So you get t squared equals 2, change in y all over a, square root both sides. T is going to equal the square root of 2 change in y all over a. But we can't use, oops, that's change in x. But we can't use this change in y, we can't use the a, so we're going to figure out, so this change in y ends up being, remember, is this 2h. And our acceleration of this block is just going to be due to the acceleration of gravity. So let's plug that in. So t equals the square root of 2 times 2h all, oops, y'all can see that, all over g. So you end up with a t equaling 4h all over g. But we can simplify that, so let's do that. So we can say t equals square root of 4 times, oops, times the square root of h all over g, and so we end up with 2 square root h over g. And so that's going to be our time, is 2 square root h all over g. So now, let's plug all this in. So let's bring this down here. So our change in x equals square root of GH times 2 times the square root of HG. Because this is our V and this is our T. But this looks kind of messy. I'm not really liking how this looks. So what am I going to do to get rid of all of these stupid square root things? Well, I'm just going to square everything. So square that, square that, square that, square that. So you get change in x squared equals GH times 4 times H all over G. Oh, well, now it becomes a lot simpler. And we can cross out our G's, multiply our H's, so we get we get change in x squared equals 4H squared. Square root both sides, and you get your change in x equals 2 times H. And so all that work for just this simple answer of 2H.